So economics and the statistical significance. So how can we use these things, result of the regression? So variable is statistically significant, and then we will discuss magnitude of coefficient to get an idea of its economic or practical importance. So once it's significant, then we can talk about how big it is and what is the effect. Fact that the coefficient is statistically significant, that does not necessarily mean it's economically or practically significant. This is the statistically significant, right? Then maybe that does not mean it's practically significant. If the variable is statistically and economically important but has a wrong sign, the regression model might be misspecified. So maybe you use a wrong formula model, or data is somewhat wrong. If the variable is statistically insignificant, then one may think of dropping it from the regression, because when we developed the statistical model, we don't want to have like 100 factors, right? Maybe your R-square is really good, I can predict pretty well, but would you handle like 100 different kind of factors, independent variable? So what we want is, yeah, of course, more accurate, that's better, but simpler model, that's better. So what we are trying to achieve is simpler but more accurate model. So whenever we have an insignificant variable, you may, why I say this may is because you will see later, sometimes you cannot drop all of the insignificant. So we will talk about later the model selection after the midterm. We will talk about it, how we handle this. But this is kind of a candidate among the factors you can drop. If the sample size is small, the effect might be imprecisely estimated. So the case of dropping in signal variable is less strong. So when you have a large sample, then evidence is strong, so maybe you can drop. But when sample size is quite small, so you have to be careful. Maybe you are dropping something important variable, right? So you have to think about it. So all of these things we will come back how we decide which one we're gonna drop. That's like a model selection topic. Significant interval. Again, what we got beta hat is the from sample, but what we want to find was the population. So population will have a y equals, right, beta 0 plus beta 1 x1 plus beta 2 x2. This is population. But we don't use all the population data, so we use a sample data. So that's why what we got is actually the estimate of the beta 0 and the estimate of beta 1, estimate of beta 2, and so on. So just like a sample mean and then trying to find out the population mean, we can create the confidence interval. So how can we create a confidence interval is just like this. This is just like the sigma, right? And this is just like a z value, but this is the critical t with a significant level, and then you just multiply the standard error, then you minus and plus, and then you can create the range here. So which means is the confidence interval, the probability that the real beta j is fall in between will be like 95%. This is our confidence level. So how can I calculate the confidence level? Is actually you don't have to. Okay, this is how we calculate the confidence interval, but I already showed you. So you have to bring the data, And attach means is you can, I don't want to type the RD cam in front of all the column names. And then this is confidence interval. This is a confidence interval. You can find out it's 95. But if you, this is the default is the 95%. But if you want to have a different level, then you can just type in the comma and then interval. Then you will have a, since this is 0.5%, this will be the 99.5%, right? And you will have a confidence interval here. If you want to find the confidence interval in the Excel, then you have to find the critical T, right? This is critical T. You can get a beta and the standard error from beta after the result of the regression. Right? From here, you can find what is the coefficient. This is the what we got is a beta hat J, and then this is the standard error of beta hat, right? So now you have to find out this t-test is our current t-test, but what we need is this critical T. So confidence interval will be the critical T times standard error of the beta hat plus minus it's a beta hat, right? This will create the confidence interval. So how can I find out this critical T? Is using this one. Is alpha is like a 95% confidence level. Means its alpha is 5%, which means it's 0.05. And degree of freedom is a degree of freedom. So how many parameters? Degree of freedom is the number of sample minus number of parameter estimated. That's why this is the usually n minus k minus 1. So k is the number of independent variable right? So how many x's, right? So x1, x, k. Then why we have one more is because this is the intercept. So testing about the linear combination of parameters. So this is a little different. So if we actually do this, what you can see will be so what we're gonna test here is not the beta j is 0 or beta 2 is 0. So what we wanna have is the null hypothesis like this. Can I tell beta 1 and beta 2 is different? So yeah, probably you will have a slightly, even it's close, is slightly different number, beta 1 and beta 2. But can we say these two numbers are statistically significantly different? Is it we got a sample error, that's why we got a slightly different number, but originally beta 1 and beta 2 are the same? That's a null hypothesis. And then if we can reject the null hypothesis, we can say beta 1 and beta 2 are significantly different. So we want to compare, okay, treat this one is my new beta. Again, this is equals to 1, so that's why we just use a t value, and then my variable is this one, right? And then my standard error is problem is now this is a random number, this is a random number. Right? So to find out, we have to find out the calculate the t value. We need to calculate this one, but actually this variable because standard error is like a standard deviation, so we have to calculate the variance of this subtraction. Then we have to find out this covariance. So if we don't have enough data, actually the beta 1 hat and beta 2 hat is the result of the sample. We cannot do this test using a lot of different samples, so this is usually not available in regression output. Actually, we have to have a lot of different set of the data to find out this covariance. So this is not available, which means this is not available, which means this is not available. So what we can do is we change the define the variable. That's what this is the same idea we said. Consider this is like a new parameter, right? So set the theta 1 is the beta 1 minus beta 2, right? And then null hypothesis will be the theta 1 is 0. And then we change it since we assume this one is right. Define theta 1 is beta 1 minus beta 2. So what we can say is beta 1 equals theta 1 plus beta 2, right? So we just replace it here, and then we expand. So beta 2 comes here and beta 2 comes here. Then you can rewrite, right? So beta 1 times JC comes here, and beta 2 times JC, you can collect this one. So now this model means I can use a JC as one of my factor or independent variable. Yeah, it was originally our independent variable, but instead of using the university, we will use this summation as the new variable. And then we run the regression, and then if you find out it's a theta 1 is a 0, can we reject this null hypothesis or not? So this technique, we have to run the regression one more time, but we don't have to look for this covariance, which is not available. So we can test null hypothesis beta 1 minus beta 2 equals 0. Okay, so this is the basically JC plus uni, right? So we have to create a new variable. So you will see the n is this much, r square is 0.22, and p-value, if you count the p-value is 0.07, which means this is like a 7%. And then as you can see here, the range includes 0, right? Since range includes 0, then we cannot, yeah, of course this 7% is greater than 5%. I don't know this, yeah, this should be, cannot reject. Null hypothesis. This method always works for the single linear hypothesis because we just replace the things. So